In this video, I am going to explain about electricity. Electricity. So, electric charges are two kinds. One is positive, other is negative. And charges can neither be created nor can be destroyed. So, 2 point charges exert force on each other according to Coulomb's law. You know, two charges, either they are positive or negative, they exert force on each other according to Coulomb's law, which states that the force between two small charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Okay, that is F is equal to Q1 into Q2 divided by D square, where Q1 is the first charge, Q2 is the second charge, and D is the distance between Q1 and Q2. It's correct? Now, potential difference. Okay, now potential difference, okay, between 2 points A and B. Potential difference between 2 points A and B is the work done per unit charge. Is the work done per unit charge by taking a charge from B to A. From B to A. Okay, the work done by bringing a charge, unit charge, it is either positive charge or negative charge, from B to A is called potential difference. The work done by bringing, okay, a unit charge from B to A is called potential difference between A and B. And potential difference at a point, a single point it is here, is the work done per unit charge in bringing a charge from infinity. Okay, the charge is to be brought from infinity, it is here now, to that point. Right? So so the potential difference, at a point is the work done by bringing a unit charge from positive to that point, and the potential difference between 2 points is the work done in bringing a charge from one point to the second point. It is right, yeah. The SI unit of potential difference is volt, V-O-L-T, volt it is. Okay, the SI unit is volt. The SI unit is volt, it is, yeah. Now, electric current. A positive charge free to move until, a positive charge free to move will move from higher to lower potential. Yeah, it's okay. Positive charge will move from higher to lower potential. Okay, just the opposite is true for a negative charge. Right? Yeah. Means what it means here now? Means a negative charge will flow from lower to higher potential. Yeah. So the flow of charge is called current. The flow of charge is called current. The charge passing per unit time through a given place is the magnitude of electric current at that place. It is here. Okay, how to measure the magnitude of a current? Means the charge that is passing per unit time, okay, through that place is gives the magnitude of that current. Okay, so the SI unit of current is ampere. Okay, so and what is ampere? So if 1 coulomb of charge passes through a place in 1 second, the current there is 1 ampere. Okay, so 1 ampere is the current, okay, when 1 coulomb of charge passes through a place, okay, in 1 second. Okay, so 1 ampere is equal to 1 Q divided by 1 second. It is correct. That is 1 ampere it is. Now, what is Ohm's law? Ohm's law, it is very important one it is here, and this is really a very important law. So the current through a metal element, is proportional to the potential difference applied between the ends. Okay, the current through a metal element is proportional to the potential difference applied between the end. Okay, so potential difference is provided the temperature remains constant. Yes, this is a condition. The temperature should not change. Okay, you can say like this here: the current passing through a metallic wire or a conductor is directly proportional to the potential difference. Right? If the potential difference is more, the current will pass more. If the PD is less, the current will pass less. It is here. Okay, provided the temperature remains the constant here. So B is equal to IR. B is the potential difference, I is the current, and R is the resistance. So which is the, okay, and this is constant for a particular element or a particular conductor. Resistance R is constant. So V is equal to I into R it is. So the SI unit of resistance is ohm. OHM it is, ohm. Okay, it is ohm. If a potential difference of 1 volt is applied across the element and the current of 1 ampere passes through it, the resistance of the element is said to be 1 ohm. It is here. So this is the definition of resistance. Resistance is the, okay, is measured. Resistance is 1 ohm when the potential is between the two, okay, ends of a conductor is 1 volt and the current passing through this is 1 ampere. Then the resistance of that conductor is 1 ohm it is. Now, the resistance of a wire is directly proportional to its length. It is, means more length, more resistance, less length, less resistance, and inversely proportional to the area of the cross section. Cross section, area of the cross section means thicker wire has less resistance and thinner wire has more resistance. Right? Thicker wire. If the cross section means this is the cross section, this is the cross section, then this is the cross section, this is the cross section. Right? This is the cross section. Okay, when the cross section is more, means if the area of the cross section is more, then resistance will be more, means thicker wire will. sorry, the it will be less it is here. So the thicker wire okay, will have the less resistance, and thinner wire will have the more resistance. Sure. So the resistance of a wire also depends on material, yeah. The resistance of a wire also depends on material. It is material. Okay, if it increases slightly with increase in temperature. Yes, it increases slightly with increase in temperature. So, the resistance uh, of a wire of the material is called resistivity. Resistivity, okay, it is known as resistivity. So that is constant for a particular element or a particular conductor. It is right. Um, Now, combination of resistors. Okay, you know, resistors can be combined in three ways. One is series, other is in parallel, and third in both series and parallel both. Okay, in a mixed in the mixed way it is here. In series and parallel both it is three ways. So if resistors are connected in such a way that the current passing through one also passes through the other resistor, so they are said to be connected in series. It is yes. So in series connection, the current in one resistor is same as the current in the other resistor. Right. The current in one resistor is same as the current in other resistor. Then that is series connection. It is okay. So the total potential difference across the combination is equal to the sum of the potential differences across the individual resistors. Okay, in this case, in this series connection, the potential difference of the resistor is different. Okay, and the sum total of the potential difference of the resistor, okay, is equal to the potential difference across the individual resistors. Now, if resistors are connected in such a way that the same potential difference gets applied to each of them, yeah, okay, they are said to be connected in parallel. So in parallel connection, the potential difference across the resistor is same, but the current is different in different resistors. It's okay? So the total current flowing into the combination, total current flowing into the resistor is equal to the sum of the currents through the individual resistors. Yeah. That's right. So the total current flowing into the combination is equal to the sum of the current through the individual resistor. Now, the heating effect of electric current. Heating effect of electric current. Heating effect. So when an electric current passes through a wire, its internal energy increases, and we say that heat is produced in the wire, of course. So the heat produced is proportional to the square of the current, the resistor of the wire, and the time for which the current flows it is. Okay, so heat produces I square RT. I square RT. Okay, so I is current, R is the resistance, and T is the time. The common unit of electric energy is the kilowatt hour. This kilowatt hour it is, right? kilowatt hour. The common unit electrical energy, this energy we pay at home. Our electric meter measures, okay, consumption of electric this energy in the form kilowatt hour. It is kilowatt hour, so that's called 1 unit. 1 kilowatt hour is 1 unit. So the electric energy produced or consumed per unit time is called electric power. Yeah. Okay. So the rate of consumption of energy per unit time is called electric power. So okay. P is equal to W by T, you can say, where W is the work done or energy and T is the time, and that is power. And power has the SI unit watt, right? Watt it is. Now, what is electrolysis? So electrolysis is the process in which an electrolyte is decomposed by passing an electric current through it. Okay, suppose if you pass electric current through acidified water, okay, this water is the electrolyte. So we will get what water is made up of. Water is made up of hydrogen and oxygen. So we'll get hydrogen and oxygen. So, okay. So hydrogen is twice the volume of oxygen in water, right? So that is called breaking of an electrolyte into its constituent element is called electrolysis. Now, what is voltaic cells? Voltaic cells is okay. So cells that produce a potential difference as a result of a chemical reaction are called voltaic cells. Okay. In a simple voltaic cell, dilute sulfuric acid is used as the electrolyte, and the electrodes are of two different materials such as copper and zinc. The hydrogen produced in the reaction takes place in the cell, okay, form as a layer over the positive electrode, so which hinders the transference of charge in the electrode. So this problem is called polarization. Yeah. In a simple voltaic cell, where the electrolyte is sulfuric acid, dilute sulfuric acid, and the electrodes are copper and zinc. In this case, hydrogen produced in the reaction taking place in the cell form a layer over the positive electrode. Yeah, hydrogen goes to this positive electrode, hydrogen, and this HCl goes to this which hinders the transference of charges in the electrode. This problem is called polarization. Yeah, because of which the cell cannot supply a steady current. Okay. Impurities present in the zinc electrode causes a number of local cells to form, which leads to the rapid wearing of zinc. This problem is called local action. Yeah. In the voltaic cell, two important words are there. One is polarization, other is the local action. So polarization is the deposition of hydrogen, okay, in the form of layer over positive electrode, and this local action is the impurities, is the formation of cells on zinc electrode, which contains impurities. Means local cells are formed on zinc electrodes containing impurities. Okay. The common dry cell is also a voltaic cell. Yeah, common dry cell that we use in torches in a dry cell. So the electrolyte consists of a paste of ammonium chloride. Yeah. Okay. Here the electrolyte is ammonium chloride as a paste, and zinc chloride. Yes, ammonium chloride and zinc chloride. Okay. So that is a paste. So, okay. Yeah. So the zinc container of the cell itself acts as a negative electrode. Okay, a mixture of manganese dioxide and powdered carbon black packed around a carbon rod together acts as a positive electrode. Yeah, see here now. Okay, a mixture of manganese dioxide and powdered carbon black packed around a carbon rod together acts as a positive electrode. Okay, so MnO2, this is manganese dioxide. Okay, also acts as a depolarizer. Yeah, depolarizer, and forms water by reacting with the hydrogen produced in the cell. Okay, so manganese dioxide, the function of manganese dioxide is to act as a depolarization, means whenever this hydrogen gas is formed, it immediately changes into water. Okay. The disadvantages of the common dry cell are the leakage of chemical caused by corrosion of the zinc cane by ammonium chloride, right? Short shelf life and inability of the cell to provide a steady current for a long time. Okay, so this is the disadvantages. So alkaline cells, which usually use KOH, potassium hydroxide, as the electrolyte, do not have such problems here. Okay. So cells in which the chemical reactions are irreversible are called primary cell. Okay, and ordinary dry cell and ordinary alkaline cells are primary cells. Such cells cannot be recharged. Cells in which the chemical reactions can be reversed by passing an electric current is called secondary cells. Okay, such cells can be recharged. So lead acid cells and nickel cadmium cells are rechargeable cells. Remember it. Lead acid cells and nickel cadmium cells are rechargeable. Okay, today this much, and I hope you will like it. Watch it. Thank you very much.